Okay, now we're going to talk about the different types of univariate data displays. Remember, uni is one, variate is variable, right? And the univariate data is data that measures only one characteristics of a population. And that data can be either numerical, or um, categorical. Had a brain seize up for a second. So, or categorical. Numericals have numbers in it. Categorical is just like different categories. Okay. So let's go back a little bit there. Okay. So there are four major ways to display univariate data. All right. There is a box plot, line. So I'll type these in. I guess there's a box plots, right? And then, whoops, control enter. And then there's a line plots, control enter. There's a stem and leaf, and there are histograms, my favorite. Histograms. Okay, and these all are going to, or have the tendency to show the frequency of something, right? If I ask, what is your favorite color, and then people, if you chose like red, blue, green, red, black, or white, or whatever, right? So it would count the number of times people would provide a certain answer. Okay, a box plot looks something like this. You have the beginning of your data set, the end of your data set, right? So like a minimum number and a maximum number. And let me go ahead and delete a portion of this like this. And from here, it's going to provide you with the median. It should be black. The median. The median is the middle of the data set. So the middle number of the data set. And based upon the frequencies of that data, why isn't it turning black there? Based upon the frequencies of that data and things like that, it'll show you how often numbers between like these down here would be like a number, like the number like we'll say like, I don't know, 20, right? And then over here would be like the frequency of like I don't know, like 60, right? And this number represents 35. Right, and that's the median number between the two based upon the number of data sets that I have. Right, and then how large these are, kind of show you how many of the average number within each of the set on that side of the median and that side of the median. That's a box plot. So let's go back and show you what a line plot is. A line plot's a little bit more intuitive. It starts with a line like this. I'll move my line down a little. Starts a line like this, and it has on this number line little slots, right? And each one of these is like one, right? We're like asked favorite number 1 through 10. So 1 through 10. I don't know if that's 10 blocks, but you get the idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. And then we'll just delete the rest of this stuff. Yeah, let's ignore this stuff. Just ignore that. Okay, we're last. What's your favorite number 1 through 10? We're picking number 1 through 10, right? And one person picked 1. 2 people picked 2. 2 people picked 3. 1 person picked 4. 5 people picked 5, or 6 people picked 5. 3 people picked 6. 2 people, a bunch of people picked 7. 3 people picked 8. This number of people picked 9, and this number of people picked 10. This shows you like the a good distribution of the data and how well the data is distributed. If it's an even distribution or it's like a little curve distribution like that, like what the shape of the data looks like. Okay, that's what a line plot looks like. Okay, this one might need to capture everything, delete, and then fill back in with black. All right, so a stem and leaf, this is a stem and leaf. It starts off, say you had a list of numbers. You had a list of numbers like, let me bring this down to like 20. We had a list of numbers like 15. These might be like this 15, 16, 16, 19, 20, 21, 23, 26. Like this is like the age people started driving something. I don't know. Or the age that, or the number of shots people made in a minute from the free throw line. 28, and it'll be like 30, 31, and 31, and 33, and it looks something like that. Okay, that is our data set. Doesn't really matter what it is, just how the data is distributed, right? So with our data set, we make a 2-column table like this and like this, and then we pick our stem and our leaf. Right, so up here is a stem, and then over here is our leaf. Right, and the stem for this is normally based upon the distribution of data or the spread of the data, is like the last number or the first number and all this. Like these are all in the tens, so we're going to have our stem for this to be 10. If this was the hundreds, we probably have this to be the hundreds. Or maybe if it was close together, it was like between 110 and 130, maybe your stem would be like 100. If they're all within like 150, their stem would be like 15. Right, but that's not the case here. Right, so our stems are going to be 1, 2, and 3. Right, so like 1, 2, and 3, and those are our stems. Let's do a transparent selection. Yeah, got rid of my line. Fix my line here. So that's our stem. Right, and then our leaves are the numbers within our second line. So we have a 5, and then a 6, and a 6, and then a 9. Right, because that's 1, 5, 6, 6, 9. Then we have in the twos, we have a 0, we have a 1, a 3, 7, 2 8s, and that's it. This is a 1. This is a 1. Right, and that's 0, 1, 3, 7, 8, 8. And then we have our 30 at 0, 1, and 3. Right, so this is what a stem leaf looks like. This kind of shows you a good concentration of the data and how the data is distributed, right? And it shows you the actual values that were collected on the display. Okay, so that's that one. And then let's take that same data set and I want to delete that. Let's delete that. What happened here? Select and delete. Okay, and then we'll fill that back up with some black ink. Okay, so now let's take this same data set and we're going to sort this up into bins. And a good rule of thumb for how many bins we need is we count the number of data points. N should be this. N equals, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data points. All right, so the number of bins we want, this is the number of bins. You'll see what a bin is in a second. Bin is, usually a good rule of thumb is the square root of 13. All right, square root of 13, let me get a calculator out real quick. is approximately 3.6. So I could use like 3 bins, or I could use 4 bins, and I guess I'll do this 4 bin, and I'll show you how to make a histogram in more details later. But we'll say like 15. Let's see, 15 to 30. It's like 15 or so. It's actually 18. So we'll do 3. 18 divided by, so between here and here, the minimum and the maximum, that's a delta of 18. Right? So 18 divided by 4 is some ugly number. So let's do 18 divided by 3, and that's 6. So we're going to make our bins 6, starting at 15. So 15, our first bin is 15 to 21. Our second bin is 22 to 27. And then our third bin is going to be 27. It's going to be 28 to 33. Okay, and then we're going to drop the number of instances for each one of these bins. So between 15 and 21, there's 1, 2, 3, 4, 5, 6. There's 6 right here. Between 22 and 27, there's 1, 2, 3. No, just 2. There's just 2 there. And then between 28 and 33 is 1, 2, 3, 4, 5. There's 5 right there. So that is the bin set. So then we would have over here the number of shots made, or the number of shots, or a frequency. Number of shots made. All right, and then over here is going to be our bin representation. And we can go from smallest to lowest. This is bin 1, bin 2, bin 3, right? Or ABC. Let's do ABC, not to be confused. A, B, C. All right, so in this group, there were all the way up to 6. And this group, there were only 2. And in this group, and this group, in group C, there were 5. So the data shape kind of looks like this, right? But it's not really in any particular, it doesn't really show me the information on the actual data set. Another way I could put this is from least to greatest, right? We change it to ABC. A, B, C. So the least on this one is B, which was a 2. So, whoops, that's a bad 2. This was like a 2. That's B. All right, the next one is at 5 at C, and then bin A was all the way up at 6. And here you can see the data like this, and the area under the curve, there's usually like another axis over here, is the percentage, right? And then whatever this lines up with here, right here, is actually closer, like that. Like it'll tell you this is how much percentage is over here. Over here is this much percentage. And over here is this much percentage of the frequency. This shows you the frequency and the relative frequency on that side. Right, so that is I like histograms so much. Right, so that's a real brief overview of these 4 different types of univariate data displays. And I'm going to go a little bit more into detail. Actually, I want to talk about, before I do that, we'll go in a little bit more detail in the next video. All right.